Shane Davis. He's our lab assistant and go-to man for everything. Just background, I had a cycle racing background, and when I looked at the track, it's very much like a criterium circuit, which is tight corners and all sorts of things that usually you need to accelerate out of. But also you need a lot of grip for. And it's interesting actually something that you said just there about the tyres. This bike won, but we had a really severe cut on the front tyre where the tube was actually exposed. So yeah, quite interesting. Could have gone very, very different and potentially catastrophic for the rider. Our rider that won on this bike, Lachlan, had a mountain bike background, doing a lot of 24-hour races, so he's a really, real gung-ho fella, but he rode it on the edge, really rode on the edge. And yes, be careful when you're doing your bikes with the tyres, really be very, very careful. It might be nice and aero and have a low rolling resistance, but you also increase your chance of getting punches. We chose a steel frame, mainly because, well, it was a bit of an experiment for us. We didn't know, well, we actually thought this hub motor would do better than the old technology, this one here. And so our plan was to just experiment and see. And we had money provided from the school, from the Grantham Council, and some parents actually gave us a lot of money as well, their donation money. So we had a bit of money to muck around with, and our plan, I mean, Shane knows a lot about motors, electric motors, and our plan was just to see how this one went. And we experimented a lot with this. We thought about the size of the motor to go 750, 550, 500, all those sorts of things. Experimented with batteries and location. I was thinking, with racing background, to get everything down as low as possible and as centred as possible. But with this motor here, as you can see, it's quite impossible to do that. So we tried to balance the batteries to get as much, get weight over this side, but even that was kind of possible as well. We had issues with the drivetrain. Our rider, we initially went geared, so this is an old 10-speed gear selector, just a lever, with a 9-speed cluster on the back, but our rider actually found that really wasn't good with the gears, so he would have rather a single speed, which is interesting. At one stage, we even in the practice, we lost a chain off the chainring, so really needed to address that sort of thing too. There's a lot of force, a lot of torque on from these motors on the chain, a lot of stress on the chain as well. So yeah, so we originally were going to go, we're thinking like an aero type bike, like a time trial bike, and we did muck around with it like that way, and with handlebars and all sorts of things. And we just found the handling was just it was just dangerous, really, really dangerous. And thinking with the track being windy, it might be risky for the kids. It's all right to have a good fast bike, but if your bike is aero but is dangerous, then you're not going to win. Yeah, so the guys actually got involved. The rider Lachlan and Alex, for that one there, got involved with the position, the setup, where did all the electric stuff with Shane and some of the guys like Matthew got involved with. And then putting it together was a real thing, because it was a real race to get things done in time. Unlike this year where you have a lot of time, last year we were very, very short for time. And as you know, as teachers, we're all fairly busy. We just happen to have a lab assistant who's awesome and who could help us out a lot. So, but yeah, so that was the main thing. Steel frame, so we could weld things. This year with the batteries being lighter, it might be a little different. We're not sure exactly which way we'll go. But we don't, we wouldn't have needed this sort of stuff here. Okay. Yeah, so we're really not exactly sure what we'll do this year. Tyres wise, it was a risk actually running with thinner tyres, as you said, like you said. So not sure exactly what we'll do there as well. You could run some sort of liner, but that affects your bike as well. So our rider was actually 72 kilos, wasn't he? Is that right? And so Lachlan on this was 72. I think Alex was about 60-ish. So we really lost a lot with weight. But I guess what we saw was it wasn't so much the mass of the rider and even the bike that's the important thing. It came down to the handle of the bike. So you've got to really choose your bike rider very carefully. Lachlan, as I said, was great at handling. He was, I guess, a third part of the equation. Get a bike that works, electrical stuff that works well, and then get a rider that can really handle it well, and that is confident as well. So, how do you?
All right, as you can see, we've got two totally different designs. Last year was a warm-up. Yeah. This year we're going to go even better. Oh yeah. They had to stop the race in the end because our bike just kept going. So we all wanted to go home. Two totally different concepts. This is a package job. that you just buy and bolt on. There's no work involved at all. You can do it in the one weekend. This motor's running at 88% efficiency, so we presumed that this bike would win. That motor there is it's the same concept as when electric motors were first invented in 1878. It has brushes, hasn't got permanent magnets, and yet that took out the prize. So don't try and go too efficient, because it all comes down to how good the bike and rider are. As I say, after 2 hours that one was still going and everything else had failed. So the reason why this one failed in the end was our controller let us down. We've got DC power meters on both bikes. At full, that's a 750 watt motor. At full power, it was actually pulling about 720 watts max. That's all we could get out of it. This one here is a 750 watt 36 volt hub motor, and it was pulling 1.1 kilowatts. And in the end, they didn't have anything left to give, so it just stopped. So look very carefully at where you get your controllers. Don't go cheap. I'm telling you now. This only cost $42 from China, come in kit. If I had my time again, I'd buy Aussie and be in contact with the guy who's given it to me and, talk to him. It's just not worth going cheap.
We had some fail anyway.
Yep, on that bike there, that's its third controller. The first two actually burned. So I got to know him pretty good, face in Sydney, parked outside his shop, and he went through it with me. So, yeah, fortunately, as Mark said, I'm a school assistant, so Shane, go and fix it. They haven't got classes, so we're a little bit fortunate there. That bike, everything come from Oakley in Sydney. Fantastic EV place, absolutely fantastic. They'll really go out of their way to help you. Everything on this bike, totally, except for the metal frame, came from China, direct from China. I think the whole thing cost us $335, not counting the batteries. And once again, Battery World, they tried to give us the batteries. And I said, you can't give me the batteries, I've got to buy them. Oh, well, how can I give them to you cheaper? And I said, the only way to give them to me cheaper is if you can sell them to anyone else off the street cheaper. Right. Well, let's have a look and see what it costs us. And I said, someone can come off the street and buy them. And he said, if someone comes in off the street and asks for that battery, I'll know what's going on and I'll sell it to them. So, yeah, I think we ended up with the same batteries, didn't we, Peter?
Yeah, I think
Battery World, unfortunately, they don't do lipos, which is where we're going to have to go this year. The Battery World, look, you can buy batteries. Yeah, really helpful. These indicators, the stop, tail, headlight and indicators, I haven't read the specs for this year, but if you have to go down that track, don't waste time on them. Just get them out of China for $18. And you get 2 sets, because the first one will probably break. We ended up with 3 and Pete ended up with a spare. Because it's just not worth spending time on, and they weigh nothing. They take like AA batteries. So I think that's about it. This one certainly would have been competitive if that didn't give that motor 1.1 kilowatts. That's ridiculous. The rider, of course, wasn't totally up to thinking about what was going on. He tried to hold his speed going up the hill. He should have just let it die and picked up going downhill. Otherwise, I suspect that this one probably would have done as well as that. So I think it's about it. All right.
So I think you can see from these that we've designed the competition rules in what we hope to be a cunning way. And so that's the 2 things. So one is that because the track is actually quite windy and the average speed is reasonably high, it's about the average speed you have to go is 30 k's an hour, that actually sits you nicely at the cusp between handling and aerodynamics. So if you can get good handling, you can do well, you can maintain corner speeds, you don't have to accelerate and decelerate, and it's fast enough for aerodynamics to make a difference. If it was any slower than that, then you've actually carried more weight than you would actually save in energy. So the actual speed is pitched deliberately at just making aerodynamics important, but at the same time as they're not critical. So handling is actually very critical. So it tests everything. It tests engine train, it tests dynamics, how well it turns, and actually aerodynamics, how we arrange the bike. And you can see that they've got foot pegs in strange positions. That was actually to work on the aerodynamics of the rider quite strongly. Also, we've designed the competition to be as easy entry as possible. So you can see this bike here is really just a, like jump on eBay, buy it off the web, bolt it on, and you're in the competition. So it's about, what was it all up?
$335 plus battery.
So $335 plus battery and a weekend and you're in the competition. So entry into the competition is as easy as possible, but the more you want to try, the more you want to fiddle with stuff, the sky's the limit. That's the deliberate design of the competition. You can be in with competitive bike very cheaply at the same time as if you want to put in more effort, there's scope in the competition to do more effort. Now all of the school teams, because the rules for last year basically said just $200 on the battery, and that's the rules really, they all went to lead acid batteries, which was kind of smart because you get a lot of bang for your buck for a lead acid battery, even though they might not last for a large number of cycles. For this particular structure of the competition, they went quite well. We also had an open competition, and we had members in that open competition, and interestingly, all the teams in the open competition decided to push things a little bit more, and they all went to lithium-ion batteries.